Hello guys, in this video we are going to discuss the solution to the problem peaks in array which appeared in the lead code round, which was it? The lead code round weekly contest for Sorotto. So this problem was basically a data structure problem where you could only solve this problem if you knew either segmentary or Fenwick tree. But I will tell you the crisp of the problem, and I will also tell you how the segmentary works in this particular problem. Okay, so basically the problem is that so they have defined peak. So they will give an array such that array A, suppose the array that the array that they gives is nums. They will give an array nums such that it has some values, and they define peak as a value such that nums of I. So nums of I is a peak if it's greater than nums of I minus 1 and if it's greater than nums of I plus 1. So in that case nums of I is a peak. So the value at the particular index I is a peak if it's greater than the value to the left side and the value to the right side. So that's basically a peak is, and they will give us some queries. So they will give us some queries, and the queries are of two types. The first type query is they will give us a range L and R. So we have to find the number of peaks between L and R. So that's what the first query does, and the thing to notice is that suppose if the element at the Lth or the Rth index is a peak when we consider the entire array. Suppose I will give an example. Suppose this is the entire array that they give us, and we have to, the L and R is between this range. Suppose the L and R is between this range. So when we consider the entire array, 4 is a peak because it's greater than 2 and it's greater than 1, and 5 is also a peak because it's greater than 3 and it is greater than 1. But when we consider this particular range, 4 and 5 is not a peak because it's at the either at the ends, and it doesn't have a value to the left side, and this doesn't have a value to the right side. So these are not peaks. But when we consider the entire array, these are peaks. But when we consider this particular range, these two are not peaks. So that is one thing to note in this. So this is the first type of query where they give us an LNR, and we have to return the number of peaks between L and R. And the second type of query is they will give an index and they will give a value. We have to change this particular index in this nums array to this particular value. That's it. You have to change the value at this the value at the nums array at this particular index to this value. That's it. And now what I did is that I basically did the range sum query. So you can actually decompose this problem. You can actually break down this problem in a sum subarray, the sum subarray problem. So sum is the addition. So what I did initially is that for the entire array, I calculated another array such that for the entire array I calculated another array, and inside that array I gave 0 for a peak, 0 for not a peak, and 1 for a peak. So this is not a peak, so I will give it 0. This is a peak, I will give it 1. So when I am creating the second array, I am considering the entire original array. So this is a peak, so I am giving 1. This is not a peak, I am giving 0. This is not a peak, I am giving 0. This is a peak, I am giving 1. This is not a peak, I am giving 0. So I created a new array like this. and I built a segment tree using this new array. I built a segment tree which using this new array, and what this segment tree do is that, what this new segment tree does is that, so if I give a particular range to this segment tree that I build, so if I give a range L and R, so if I give a range L and R, suppose the range L and R is the entire array. So if I give the entire array as a range, what it does is it finds the sum of all the elements in between these range. So the sum of all the elements inside the entire array is 2, right? Because there are 2 ones over here, so the entire sum is equal to 2. So if I give it a range, it will find it will return the sum of the entire range. So that's what my segment tree does. So it's a sum segment tree. So it's a segment tree to basically keep track of the sum. And I will also show you the point update. So like if you know segment tree, you know that it's very easy to update an index in a segment tree in log n time. So it's basic. Like I don't think it's useful for me to explain segment tree in this problem. In this video, like you can refer some video to learn about segment tree, and you can come back to this video. So when you refer some segment tree videos, you will learn a function called point update. So point update is basically you can update a particular value. So in this case it's the index in log n time. So in log n time you will update this index, and you will change the entire segment tree in log n time. It's much efficient. So we can use point update for the second type of operation, and for this first type of operation, what I did is I found the sum query, the range query, sum query on that particular range. But the problem is that, so if we find the range on this particular range, as I told in the first example. So if I find the range, if I take this range, it will include these endpoints as well, right? It will include these endpoints as well. But as I told you before, we don't need to include these endpoints, because even though they are peaks in the original array, when we take this particular range, when we take this particular range, they will not become peaks, because they will become the endpoints, and they will lose the status of peaks. So we have to somehow avoid them. So when we consider a particular range, so suppose this is the range that they have given us, we will trim the range to this. So we will find the sum of this range. If we find the sum of this range, we will not include the sum of these two values. If those are peaks over there, we will not include the values of those two peaks, and we will just find the sum of this range. So that's what basically the only observation that we have to make, I guess. So if we have to find the range of this one, what I do is, if they in the question they have asked us to find the range of L and R, what I do is I will find the sum in between the range L plus 1 and R minus 1. In this way we will exclude the values at the end. So even if they were peaks in the original array, they will not become peaks in the new range. So that's basically the observation that we have to, the only thing that we have to make. I will show you the code for this problem right now. Yeah, so I will show you the code for the problem now. So the code is also very simple. It's basic segment tree implementation. I haven't done anything extra to it. So the only catch is that you need to know, if you know segment tree, it will help you in understanding the problem much easier. So I will explain the code. So here is the build function. So I will start from the main code. So I am creating another new vector. Initially I am initializing all the values as 0, and if I encounter a peak, I will set that set the value of that index to 1, otherwise 0. Then I am building the segment tree. How I am building the segment tree?
So it's a standard segmentary implementation. If I am reaching the a single a node with a single value, I am initializing the segmentary as the value. Then I'm returning. Then I am setting the value of the parent node as the values of the of its uh, two children, the value of the parent child as the sum of the values of its two children. So this is the implementation for a sum segmentary. If you like, there are other implementation segmentary where you find the maximum element in a range and stuff like that. So for that, like, you what you basically do is that you remove that plus sign and you put max, so you will get the maximum of your two children. So since I want the sum of my two children, I'm adding the in the values of the two children. And for the update operation, I have a position and I have a value. I have to change the value at this position to this value. So when I reach that particular value, I am updating the segmentary as the value, the node, the segmentary node as that value. Then I'm returning. Then I am doing the update operation. This will only take log n time, since I'm only like going through one branch at max. And this is a query operation. So we will have a range. Left and right will be the range. So we want to return the sum in between this range. So when we raise a particular range, we will return the value in that particular node of that range. And that's it. That's basically the query operation. Yeah, so we will iterate through the number of queries that they have given us, and if the queries of the first type, what we will do is that we will do a query on the segmentary. As I've told you, we will do L plus 1 and R minus 1, because we want to not consider the two values at the either end of the range, and we will find the sum, and we will push that to a vector answer. So we will at the end return this vector, because they have asked us to return a vector at the end. But if the query is of the second type, what I'm going to do is that I'm going to update the value at the position that they have given us to the value that they have given us. And now we have to check whether, after updating this particular position, whether that if the value was already a peak, it may sometimes lose its status of a peak after updating that particular position, right? So we have to check for that. And not only that, but by updating the ith position, it can also affect the I minus one position and I plus one position, right? So suppose if the I minus one the position was a peak because of this value, and if by updating this ith position, the value of the ith position became larger than the I minus one position, the status of the I minus one position will also lose, right? The status of peak of I minus one position will also be lost, right? So we have to keep track of that possibility as well. Not only the ith, whether not only we have to keep track whether the ith position will become a peak or not become a peak, we have to check for the I minus one and the I plus two indices as well. So that's what I'm doing. That's what I'm checking over here, and I'm updating. So if it becomes a peak, what I'm gonna do is that I'm gonna give it a value one. If it doesn't become a peak, if it doesn't become a peak, or if it was already a peak and if it became not a peak now, I will give it a value zero now, zero, and we will change the value in the segmentary to either one or zero. And similarly, we do it for the I minus one index and I plus one index. Yeah, so this is basically the problem. and the solution. I will share the code for the solution in the description of the video. Thank you for watching. And can you comment out whether you have understood the solution or not? If you have not understood the solution, what can I do better in the future to improve my explanation skills, or what can I improve in the further videos? And if you have understood the solution, please like or subscribe. Thank you.